Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have to evaluate this definite integral using integration by parts. So first, let's recall what is integration by parts. So if you have an integral of the form u times dv, then you can use the by parts formula to rewrite it as uv minus integral v times du. That is integration by parts. So look at our integral here. We have x to the 5 and natural log of x, two different functions. So if we want to use integration by parts, we have to rewrite this in this form u and dv, which means we have to choose which function is u and which function is dv. Before you make this choice, just think about it for a second. Notice that whichever function you will choose as u, you will have to differentiate that function so that you can get du. And whichever one you choose as dv, you have to integrate that function to get v from there. And that's very important to think about. There are two functions. Which one is easier to integrate? What about natural log? Is it easy to integrate? Not really. We actually have to use integration by parts to evaluate that indefinite integral of ln of x. But x to the 5, you can integrate easily, just power rule of integration. So that should tell you how to choose u and dv. Now, before we solve this definite integral, let's solve the indefinite integral first. So let's just consider this integral without the limits 1 and e, and rewrite this function as natural log of x, x to the 5 dx. We're just switching it because we want to choose x to the 5 as our dv. So let's do that. This is u and this part is dv. Okay, so let's go back here and write our u and dv down. And then from there, evaluate du and v. So what is du? You just have to differentiate natural log, which is 1 over x dx. And if dv is x to the 5 dx, what is v? You integrate x to the 5 using power rule, you get x to the 6 over 6. Okay, let's come back here. So this is u dv and we are applying integration by parts. So we have to write it as uv minus integral v du. And we have our uv and du, everything written out here. So we just plug that in. So let's see. U is natural log of x. V is x to the 6 over 6. Minus, you have another integral of v, which is x to the 6 over 6, times du. Du is 1 over x dx. Okay. So the first term, just rewrite it. For the second term, look, there is another integral that we have to evaluate. First, notice that this 6 in the denominator is just a constant, and the constant is actually 1/6, so you can pull it outside the integral. Now, inside the integral, you have x to the 6 divided by x, so you can cancel one of the x to get x to the 5. So we have first term, write it as it is. For the second term, integral of x to the 5, we have done it before right here, and you can apply power rule to say this is x to the 6 over 6. and then plus constant because this is the indefinite integral. So one more step. Just rewriting the 6 times 6 as 36. All right. So that's the indefinite integral. But we have to evaluate the definite integral. So how do we do that? All we have to do is take the antiderivative that we just evaluated and then plug in e and plug in 1 and then subtract them. So take our antiderivative, x to the 6 natural log of x over 6 minus x to the 6 over 36, and you can ignore plus c when you are evaluating a definite integral, and then you have to just evaluate them at these 2 points, these 2 limits. So first plug in e wherever there is x. So you get e to the 6 ln of e over 6 minus e to the 6 over 36. Then you have to subtract the expression when you plug in 1 for x. So you have 1 to the 6 is 1. So you just have natural log of 1 over 6 minus 1 over 36. Let's simplify this expression and we will have our solution. Okay. Notice that natural log of e is just 1. Natural log of e is 1. And also notice natural log of 1 is 0. So we have e to the 6 over 6 minus e to the 6 over 36. Now, this first term, this ln of 1 is 0, so this entire thing will be 0. So you will have negative and a negative, so a positive 1 over 36. Okay, now if you take out a common factor of 1 over 36 from all 3 terms, you will be left with 6 e to the 6 minus e to the 6 plus 1, and that is equal to see 6 minus 1, that's 5 e to the 6 plus 1. So this is the solution to this definite integral. Thank you.